Hello everyone. So we have got a good question from the chapter of limits. So in case this question is not, this is limit x tends to 0 cos ax to the power cos x square bx. Okay. So if we have a look at what will happen if you put 0 in this particular expression, if you see cos ax, if you put x equal to 0, this will be 1, and cos x 0 is basically 1 by sine 0, right? And sine 0 is 0. So this is in the form 1 to the power infinity. Now, whenever we have got such a weird looking expression, when we are getting say 1 to the power infinity or 0 to the power 0, or basically any indeterminate form which has got uh, you know in the form which is in the form of a power, the first thing which we do is we consider this particular limit to be as say a term y, and then we apply natural log on both the sides. So this will be natural log of y is equal to limit x tends to 0 cosec square bx natural log of cos ax, right? This is what we get. Now let's try to make our lives easier. Okay, cosec square bx, we can write this as sine square bx, right? Now we know that limit x tends to 0 sin x by x is equal to 1, right? And similarly, limit x tends to 0 x by sin x is also equal to 1, right? So we will now apply this over here. Let's do one thing. Let's multiply both sides, that is the numerator and denominator, with b square x square. Okay, and we have got ln cos ax, right? So this entire term essentially becomes 1. Okay, so yeah, so we can now reduce this expression to limit x tends to 0 1 by b square x square natural log of cos ax. Now we are aware of the fact that limit x tends to 0 ln 1 plus x by x is equal to 1. We are aware of this, right? Where x tends to 0. Now here we can see that cos ax tends to 1, right? I'm sorry, not 1. Yeah, it tends to 1. Okay, so it does not tend to 0. So we have to make it tend to 0. So what we can do is, this is what we can do. Limit x tends to 0, 1 by b square x square, and we'll basically add and subtract 1. Okay, now we can compare this portion with the x in this particular expression which has been given. So now this entire thing, this tends to 0, and this is 1 plus 0, right? And let's do one thing. In order to get 1, we need to divide this with x. So when we divide this with x, we get cos ax minus 1, and we multiply cos ax minus 1 in the numerator as well. Okay, so uh, this thing becomes 1. Why? Because of this property. Because of this property right here. Okay, so this is what we are left with. Limit x tends to 0, 1 by b square x square cos ax minus 1 cos ax minus 1. Okay, now I'm not sure if you're familiar with this, but you can familiarize yourselves with this, because this is something very important. And this is, yeah, this thing is equal to half. Okay. I'm sorry, not this, but rather this. Okay. Why this value is half, you can find this out yourselves using the L'Hopital rule. Okay. But, if you differentiate both sides, you will get half. Okay. So we are going to use this property now. Um, so this will be minus limit x tends to 0, 1 by b square x square, 1 minus cos ax, right? Now we have to divide this with a square x square and multiply it with a square x square. Okay, in order to equalize the numerator and denominator. So this entire thing becomes half. Why? This property. This property. Okay. So now, as we can see, we can cancel out this x square and this x square. So the natural log of y, it becomes minus a square by 2b square. This limit x tends to 0 does not make a lot of sense because there is no term related to x now left. Okay, so this is what remains, and so the value of y is e to the power minus a square by 2b square. Okay, that is the answer for you. And so the answer is, yeah, this one. This is the correct answer. Thank you.